Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at abstract classes in Java. And abstract classes are something that you can use when you want to start creating a class hierarchy, but the base class is not going to be able to do anything in itself. It's only going to act as a base for other classes. And let's take an example of this. I might decide that I want to have a base class called machine for my class hierarchy, let's say. So I'll create a machine class. And I might have a bunch of different subclasses, like for example, a camera is a machine. So I might say public class camera extends machine. And a car is a kind of machine, so I could say new class car, and I could also say that car extends machine. Now it may be that in whatever program it is that I'm creating, both cameras and cars have some functionality in common. Let's say, for example, it may be that both the cameras and the cars in my program have IDs. So if they have something in common that's common to all of the machines in my program, then I could add that common functionality to the parent class, which makes complete sense. So I could say private, let's say int ID, and I could right click and go to source and generate getters and setters, and I could generate a getter and setter for ID, and then every machine that extends this class has an ID. Now so far this is a completely conventional class hierarchy, and now I can do stuff like camera cam1 equals new camera, and cam1.setID 5, and the same for car, like car1 equals new car, and car1.setID 4, or whatever. You get the idea. But I might say, well, what exactly would machine, why would I want to create a machine object? Like, I might say machine1 equals new machine, but what the hell is this? What would I use it for? And I might decide that while there's a purpose in having a camera and a purpose in having a car, there's never going to be any value in having a machine, because all machine is it's a base class that implements some common functionality that any machine has, but there's no such thing in itself as an abstract machine. I could decide that, indeed in the real world we have cameras and we have cars, but unless you go to like a modern art installation or something, you don't have a completely abstract machine. You only have specific machines. So I could prevent the user of this class hierarchy from instantiating the machine parent class, and to do that I just make it abstract. So I say public abstract class machine. And what that does is it means that now if I try to type machine1 equals new machine, I can't do it because machine is abstract, and as it says, I cannot now instantiate the type machine, which is what I wanted. Now this is an abstract class, and abstract classes can have abstract methods, because let's say I now want to force all machines to have a method called start, because I might think, well, every machine that I'm going to have in my program has got to have a start method to start it up somehow, whether it's a car or a camera or whatever it is. And cameras these days are usually digital and you have to start them up. So to do that I could have an abstract method, and this will be appropriate if I want to force all my child classes to have this method to implement it, but I don't want machine itself to implement it, because the implementation is going to be completely different for every particular kind of machine. Then I can say public abstract, and let's say that this is going to it's not going to return anything, and it's just going to be called start. And then instead of having brackets here, I just put a semicolon, so it's exactly like the declaration of a method in an interface. And now I get an error here because I've got to implement start now in camera. So if I click the error, I can go to add unimplemented methods, and the same for car here, and they can have whatever implementation would make sense for this particular class. And this is of course very much like using an interface, and we're going to talk about that in just a second. But first, let's put in an implementation here for car as well, starting car. And you can even do stuff like let's say you've got a run method. Let's say that every machine has a run method, public void run, and I could even like call an abstract method here. So I could say start in run like that if I wanted to, and I could have more abstract methods here like public abstract do stuff, public abstract void do stuff. This is like a kind of ridiculous name, but just to illustrate the principle. And public abstract void shut down. And I could call all of these methods in run, even though they're abstract here in machine. So I could say start, do stuff, and shut down, which can be quite handy. So I'm supplying quite a lot of the implementation in machine, but it's just that the bits of implementation that I want to force the child classes to handle, I just don't declare here. I just make that those methods abstract and force the child classes to implement them. So now we've got to implement some more methods in here. And now, of course, I can call stuff. I can do stuff like calling car1.run, and this is just going to say starting car because I didn't supply any implementation for do stuff, but I could do that. And that's pretty much all there is to abstract classes. But one thing that I want to just talk about a little bit now, let's say just shut down car, but you get the idea. One thing that often confuses people is, because this abstract method is forcing the child classes to handle that, and that's very similar to an interface. When you implement an interface, you force the user of that interface, you force the class that implements that interface to implement certain methods. And for that reason, people often get confused about when to use an abstract class and when to use an interface. And there are several things to bear in mind, and that the most key thing is that when you make a class the child of an abstract class, by having that abstract parent class there, you're really making a very strong statement about what the child fundamentally is. So with an interface, we could have like I could have an interface called info, for example, with a method called show info, and a machine could implement this show info interface, and so could a person, or so could a building class. Anything can implement show info, and we would simply be saying that a class that implements it has this functionality of being able to display information about itself, let's say. But when you say that a child class fundamentally extends a parent class, like this extends machine, I'm really making a very strong statement, and I'm saying that camera is a machine, and I'm saying that car is a machine. So the parent class determines its fundamental identity, and when you have a abstract class as the parent class in a hierarchy, you really have to make sure that the child classes, they are going to be whatever that parent class is. A car is a machine. So an abstract class, extending an abstract class is a much stronger statement than simply implementing an interface. And another thing to bear in mind is that a class can implement many interfaces, but it can only have one parent class. So it can only have one abstract class in the hierarchy. So you're only going to be able to extend one abstract class, but you can implement as many interfaces as you like, which again kind of reflects the fact that extending an abstract class is just really a more fundamental statement about identity than simply implementing an interface. It's as if the parent class determines what your child class is, but implementing an interface just determines one thing that it does, and it can implement many interfaces, meaning it can do many different things. And another consideration is that you cannot have code in an interface, but in an abstract class you can provide default functionality. We can actually have real functionality in an abstract class like machine here, but in an interface you're leaving the implementation completely up to the child class. So you can't put code in an interface, and once again that really has to do with the fact that if you extend a parent class, your child class has the fundamental identity of the parent class and can even take functionality from it, whereas in an interface it's completely up to the implementing class what implementation is in there. It's the interface purely only defines the form of the methods that your class has, and it doesn't provide implementation. So that's it for this tutorial, and abstract classes are a great tool to use whenever you're starting a class hierarchy and it just makes no sense to have a actually implemented object of the root in that hierarchy. So they're a thing that you'll use occasionally, but probably not nearly as often as you will use interfaces. You can find this code on caveofprogramming.com, and until next time, happy coding.